Hi folks, my name is Jeff Talkington and I'm a systems engineer for Palo Alto Networks. Today we're going to talk about DNS sinkholing. We'll talk about why we need to do DNS sinkholing, how to configure it on the Palo Alto Networks next generation firewall, and finally how to test and verify that it's working properly. Okay, let's take a look at the problem we're trying to solve. In the lower left we have a user machine that's been infected by malware. As part of the malware process, this infected machine is trying to reach out to a command and control server, which I've labeled attacker. When the infected user does a DNS request, it will be to the internal DNS server. Since this domain is not hosted locally, the internal DNS server will forward the request to the external DNS server, passing the request through the Palo Alto Networks firewall. Depending on policy, we'll either be blocking or alerting on this resolution to a suspicious DNS domain. But the logs won't give us the information we need. You see, the logs show that the request came from the internal DNS server and will not show us the infected machine. What we're going to do with the DNS sinkholing is intercept that DNS request between the internal DNS server and the external DNS server and respond with an address of our own. Starting in PAN-OS version 7.1, Palo Alto Networks began resolving suspicious DNS queries to the IP address 72.5.65.111. It is a predefined Palo Alto Networks address that will live on our firewall and direct the infected user to the firewall to be blocked and logged appropriately. Let's go to the demonstration so you can see this in action. Okay, so to get started with our demonstration for DNS sinkholing, I've pulled up our next generation firewall, and the first thing we're going to do is make sure that we have our licenses and our dynamic updates are good to go. Now, with our licenses, obviously we need to make sure we have a support license, but the main thing we need to make sure of is that we have a threat prevention license, and you can see that we do, and it's still valid. Now, our threat prevention subscription, that license is what gives us a lot of the Content ID capability, where we can do network-based antivirus, we can do our IPS signatures, and in this case for DNS sinkholing, we get our command and control or C2 signatures. So that's valid. Let's move on to dynamic updates. Within dynamic updates, we need to make sure we're getting the antivirus updates. That antivirus update is what's going to give us those C2, those domains that we're going to be checking against. If we look over here to the right, something to take note of is that we can look at the release notes. The reason I'm telling you this is if we click on the release notes, what will happen is another tab will pop up. We'll show you the release notes. This will show you all of those C2 signatures that we will be putting into this particular release, and will show us those domains that we consider to be suspicious. So when we look to do our verification and testing, this is a great resource for finding a domain name to use for testing. In this case, I'm going to use this one that I have highlighted here, this cutcx.biz. So we'll do our testing against that and make sure everything works as it's supposed to. Okay, so now that we've done that, we'll move on to step 2, where we're going to configure DNS sinkhole protection inside our anti-spyware profile. So let's go ahead and do that. We'll jump over to the Objects tab, and under Security Profiles, I'm going to click on Anti-Spyware. Now, we've got some default profiles. What I've done is created my own custom profile called Alert All. Within that, I'm primarily just alerting until I do my DNS signature portion. So within DNS signatures, I'm going to set my action to sinkhole. And we've got the option, there's a drop down here where we can do alert, allow, block, or sinkhole. Obviously for sinkholing, we'll choose the sinkhole option. Beneath that, what we'll do is select our sinkhole IP address, the IP address that we're going to serve up as the DNS resolution for suspicious DNS queries. In this case, there's this predefined IP address that I told you about, this 72.5.65.111. So we'll take note of that. We also need to have an IPv6 address. This is just going to be the loopback IP, and that should be enough for us right there. Once we do that, we can move on to step 3, where we apply this to the policy itself. So let's go into our policies, And where we need to apply this is where we're impacting traffic going out to the internet, where we're impacting traffic that's doing this DNS resolution between the internal DNS server and the external DNS server. In this case, it's policy number 3, my allow outbound. So what I'm going to do is within here, we're allowing the traffic, but if you look at my profile settings, we've changed our anti-spyware to that alert all profile that we just set up. Okay, so that's all set. The next thing we need to do is we need to create a rule to block that DNS sinkhole IP. So that 72.5.65.111, once we resolve to that IP address, what we want to do is block traffic going to that IP address and then log it. So the only way to do that is to create a policy for it. So what I've done is created this block DNS sinkhole policy, this policy number 1 here. And what we're doing is we're doing a deny based on traffic going to this predefined IP address, that sinkhole IP, the 72.5.65.111. Something to take note of here is that we had to create this object. Now, it was predefined when we were creating it within the profile, within the sinkhole IP, within our profile for anti-spyware. But unfortunately for the security policy rule, you will have to create this address object in order to make this work. So create this object. I went ahead and called it sinkhole 72.5.65.111, so I know exactly what this is. Once we do a deny on that, also make sure you're logging that so that we get that within our traffic logs. Next thing we're going to do is we're going to go to our Windows 7 box, and we're going to generate some traffic, and we're going to make sure that we're sending something that we can check the logs against. So on my Windows 7 box, what I've done is we're doing an IP config, so you can see that the IP address is 192.168.45.147 for this machine. The next thing I'm doing is an NS lookup for that suspicious domain, that cutcx.biz. And you can see that we do a resolution, and the IP address that we're getting is in fact that predefined IP address, that 72.5.65.111. Okay, so that's all working fine. What we need to do now is check our monitor and make sure that we are seeing this traffic. So we'll look at the traffic. And what I want to do here is create a filter specifically for that destination IP address, that 72.5.65.111. I've done that now, and what you can see is that we have IPs, specifically this is my Windows 7 IP, that 192.168.45.147, going to the predefined DNS sinkhole IP and being blocked by our rule, the block DNS sinkhole rule. So now we're appropriately logging these connections from an infected host trying to reach out to a command and control server. So immediately I know that this is an infected host. One of the other things we can do is create custom reports around this. And you'll see that what I've done is I've already created one here, and let me show you how this is all set up. But you can do this by going to Manage Custom Reports under the Monitor tab. And here I've created a report called Sinkhole. So if we look at that, what I've done is I'm taking a look at the traffic log. Make sure that you're doing this if you want to see these sinkhole IPs or what we've denied using the sinkhole address. That's going to be in the traffic log. The other thing we're going to do is we're going to do a query builder. So I'm going to add a query specifically for this particular destination IP address. So let's go in here, destination address. We'll set it to include, and we'll put a value of 72.5.65.111. We'll select add, and then we'll click on OK. And then what we can do is we should be able to run this and you'll see that our address, this is our Windows 7 box, and it's going to that Sinkhole IP. I've also done some NS lookups from our internal server, our internal DNS server, so you'll see that on here as well. But since we know this is our internal DNS server, we know we could ignore that. The one we'll need to take a look at is this 192.168.45.147. Now, the great part about this is, now that I have a custom report, I can simply export this to a PDF or CSV or XML file. I can send this over into a ServiceNow ticket automatically if I want to. We can email this out to our help desk and send them out, and they know for certain that they have an infected machine that's trying to reach out to a command and control domain. So very quickly here, what we've done is we've created a way where we can see infected users trying to reach out to command and control servers. We've created our DNS sinkhole. We've been able to create a deny rule that allows us to block that and log it appropriately. We're able to see that in the traffic logs. And finally, we're able to create a custom report so we can go out and we can remediate these devices. Thanks for watching.